Welcome to this explainer. You know, for literally thousands of years, the night sky was humanity's absolute greatest mystery. But today, it is quietly transforming into our most vital, bustling infrastructure. Today, we're exploring the future of space technology. Specifically, we're going to look at how the cosmos is actively rewriting the rules for our everyday lives right here on Earth, right now.
So we really have to ask ourselves, what actually happens when space becomes humanity's next industrial frontier? I mean, it's a massive paradigm shift, and the sky is no longer just this beautiful canvas for our imaginations or a destination for a handful of highly trained astronauts. It is literally humanity's newest workplace. And building an industrial frontier in orbit, that means servers, factories, and power plants physically moving off-world. We're laying a brand new foundation for how our entire civilization operates down here.
Okay, let's dive into this. Every single time you check the weather on your phone, navigate through terrible traffic, or make an international call, you are relying on an invisible engine. This space infrastructure already powers modern civilization. It optimizes agricultural yields. It monitors natural disasters in real time. It does so much. But here's the crazy part. This is just the baseline. The next big shift isn't just about putting things up in space. It's about building a robust economy from space. The rockets and satellites we have right now, they're really just the prologue to a much larger transformation.
To really wrap our heads around this transformation, we'll follow a quick roadmap today. We'll trace this journey starting with 1, the catalyst, then we'll check out 2, the orbital economy. Look at 3, emerging technologies. Discuss 4, navigating friction, and wrap up by looking ahead at 5, the next 50 years.
All right, let's kick things off with Section 1. The catalyst, the new space race. And honestly, there is one specific innovation that has made space dramatically cheaper and more accessible than anyone thought possible. So, we've totally moved on from the Cold War era of spaceflight. Back then, it was entirely government-funded, right? Heavily driven by geopolitical tension and focused pretty squarely on national prestige through the really monumental achievements of agencies like NASA and the ESA. But now, we've entered the modern space race. This new era is highly commercialized, is driven by economic viability, and it's fueled by billions, with a B, of dollars in private investment from companies like SpaceX, Blue Origin, and Rocket Lab. But it's important to note, this isn't a replacement of the old guard. Today's commercial titans are actually actively partnering with legacy agencies like JAXA and ISRO to collectively build this future together.
Now, what's really interesting about this data is the sheer cliff dive drop in launch costs. Historically, using legacy expendable rockets meant building a multi-million-dollar machine, flying it exactly once, and then just letting it burn up or crash into the ocean. That kept the cost to reach orbit astronomical. We're talking sometimes tens of thousands of dollars for a single kilogram of payload. Early commercial rockets started optimizing this, sure, but the introduction of modern reusable rockets completely changed the physics of finance. The ability to launch a rocket, land the booster autonomously, and fly it again drove that price tag down toward $1,000 per kilogram. That fundamentally alters the economics of leaving Earth, totally opening the floodgates for innovation.
Which brings us to Section 2, the orbital economy, expanding the frontier. Because as launch costs fall, the rocket itself isn't the biggest breakthrough anymore. It's what that rocket is carrying.
$1 trillion. Let that sink in for a second. With costs plummeting, our focus is completely shifting to the infrastructure being deployed because that is what creates a new economic frontier. Verified data from premier organizations, we're talking the Space Foundation, Euroconsult, Bryce Tech, they all predict this will become a $1 trillion industry by the 2030s or 2040s. Private capital is just pouring in because investors realize the next great technological revolution isn't happening in Silicon Valley, it's happening in orbit.
So, where is that $1 trillion actively being distributed? It's spread across several massive commercial ventures that all directly interact with each other. First, you've got satellite internet constellations blanketing the globe to provide high-speed access literally anywhere. At the same time, they're beaming down petabytes of Earth observation data from companies like Planet Labs and Maxar, who are monitoring everything from global supply chains to climate patterns with stunning precision. In parallel to all that data, we are seeing the actual dawn of space manufacturing. They're utilizing microgravity to pull flawless fiber optic cables that are literally impossible to create under Earth's gravity, and to house all this new industry, commercial space stations. Privately owned outposts by companies like Aerospace and Vast are actively being developed right now to eventually replace the aging International Space Station.
And to make all that happen, we need Section 3, Emerging Technologies, Powering the Future.
Because AI and advanced engineering are the invisible forces supercharging this whole orbital economy. And this brilliantly illustrates how we're upgrading our tools. Nuclear propulsion. To sustain a booming off-world market, the infrastructure demands advanced engines. Utilizing nuclear reactions rather than traditional chemical combustion to generate thrust changes the math entirely for long-distance space travel. Actually, scratch that. It changes the entire reality of it. Instead of a dragging 9-month drift to Mars, nuclear, thermal, or electric propulsion could cut that trip down to 45 or 90 days. By drastically reducing deep space travel times and vastly expanding payload capacities, nuclear propulsion transforms the outer solar system from this distant sci-fi dream into a practical, accessible reality.
Another mind-blowing concept currently under development is space solar power. Imagine this: autonomous spacecraft positioned in high orbits, just basking in 24/7 sunlight without any interference from weather, clouds, or, nightfall. They collect solar energy continuously and then beam it directly down to Earth as microwaves to be converted into electricity. This is a perfect example of space technology not just for exploration, but to solve one of Earth's absolute most pressing terrestrial crises: infinite, clean energy generation. But as you might guess, projects this massive face some serious hurdles.
Which leads us directly into Section 4, Navigating Friction, the reality check. Let's take a very frank look at the challenges ahead.
Building an economy in the harshest environment known to humanity means facing some intense, complicated friction. For starters, we are seeing a rapid accumulation of orbital debris. We're talking about space junk traveling at tens of thousands of miles per hour, which demands immediate advancements in space traffic management. Simultaneously, we're operating under these complex, often outdated global regulations. We have to balance environmental sustainability with rising international competition and, let's be honest, very real military concerns. As space gets more crowded, geopolitical tensions naturally extend right up into orbit.
Let's break down the specific impacts here neutrally, because a single stray piece of debris can threaten a multi-billion-dollar infrastructure. Things like active cleanup technology and AI-driven traffic systems aren't just nice ideas. They are absolute requirements for survival up there. And as these physical threats grow, the lack of unified global regulation actively slows down commercialization. It creates massive legal uncertainty for private companies trying to innovate. Furthermore, military concerns heighten geopolitical tension, requiring deep diplomatic transparency and the establishment of neutral boundaries. It's exactly why heavy-hitter organizations like the OECD and the World Bank are tracking these regulatory and economic risks so incredibly closely. International cooperation is absolutely critical here.
Let's move to and see how this builds into our final section, Section 5, the next 50 years, the horizon. Let's look at humanity's next giant leaps.
When you look at the timeline of tomorrow, the progression over the coming decades is highly deliberate. In the near term, deploying commercial space stations and dialing in AI navigation sets the baseline. Getting that operational experience allows us to transition into the midterm goal, which is permanent lunar bases. We basically have to learn how to extract water and manufacture habitats on the moon to prove we can actually survive off-world for the long haul. Mastering that midterm lunar infrastructure acts as the essential stepping stone for the long-term realities. That's when we get to the wild stuff: asteroid mining for rare earth metals, deploying AI astronauts for deep space construction, and finally, establishing a permanent, sustainable presence on Mars.
I want to leave you with this thought. Every generation has explored a new frontier. Ours may be the first to build one beyond our own world. The future of global communication, of climate monitoring, of our biggest scientific discoveries, it all depends on what happens above us. The future is arriving faster than ever, and your daily life on Earth is now forever, permanently linked to the stars. So as this orbital economy explodes into reality over the next few years, what role will you play in humanity's next greatest frontier? Thanks for joining us for this explainer, and we'll see you next time.
Thanks for watching World Decoded. Make sure to like and share, subscribe, and stay curious.